Good morning, Professor Rajeshwari, and all the students who are attending this session. First of all, I'd like to welcome you to this session of a basic awareness about this most hyped technology, Internet of Things. So on behalf of Collabora Tech, I welcome you all to this demonstration of IoT. And let me take this opportunity to introduce Collabora Tech first. This is Technology Academy for Competency Training, a training branch of Collabora, which is a 550 million US-based IT staff augmentation company, operational in 3 verticals: IT staffing, development, as well as into training. Collabora Tech is the training arm of Collabora, and through Collabora Tech, our vision is to make learning easy and affordable for millions of IT professionals across the globe by providing a state-of-the-art platform which can be accessed from anywhere. So with this vision and strong mission statements, we have been operational in more than 70 countries, and 75% our clients rank us in their top 3 suppliers based on performance. Okay. Basically, Collabora is known for its IT staffing capabilities, but we are also a leader in technical training domain, offering more than 10 courses in different emerging technologies domain. IoT is one of the domain where we have been offering training programs to professionals as well as academicians. See, most of our training programs are award-winning, and the IoT training has been recognized as best training in India by Analytics India magazine. At international level, we have bagged many awards and recognitions. Few of the awards and recognition certificates are listed here. Okay. Let me introduce myself. My name is Shafi Patel, and I am the senior SME of IoT at Collabora Tech. I have more than 18 years of experience in electronic system design and manufacturing, embedded systems, communication engineering, and IoT domain. I trained more than 8,000 engineering graduates in last 10 years, working as a professional trainer in these domains, and more than 500 corporate professionals on these technologies. Okay. Now let me introduce the person who coined this term, Internet of Things, is Mr. Kevin Ashton, and Mr. Kevin Ashton used this term, Internet of Thing, in one of his very famous presentations. See, before starting with why I'm showing you this slide and apart from his interview, is that before jumping into the core technical discussions over IoT, let us try to understand the concept, the idea conceived by this person. His idea, actually, what his idea was, is to empower the computer systems together lots of data and transform this into information to manage things, processes, operations, or environment in more efficient manner than humans do. So his idea was to delegate more and more responsibilities of managing everything, from our life to businesses to factories, delegating these responsibilities to computers. And the idea was that the computers are capable enough of managing things and processes in more efficient manner than human beings. Okay. So let us try to understand whether his idea is in sync with the okay. Okay, let us try to understand whether his idea is in sync with the current technology developments or not. Okay. See, when it comes to managing anything, let's talk about our industrial processes or our life or our day-to-day activities, or this world we are a part of. See, this world is basically made of smaller objects, and managing the world means knowing about the object first. We recognize objects on the basis of attributes. The attributes are unique properties of each and every object this world is made of, right? And the values associated with the attributes of objects, this collection of values, is called data. So there is a newer and formal definition of data. It is defined as the values associated with the attributes of the objects this world is made of, right? So to manage anything, first we need to know it, and to know something we need to collect lots of data. This data is actually the values of the attributes of objects, right? So there is something called a knowledge discovery process, and this process of discovering the knowledge is being utilized in almost all the domains of our real life to manage businesses, factories, as well as many other things. Right? So this knowledge discovery process has a series of steps. It all starts from collecting data, and as I explained you, the data means the values associated with the attributes of the objects, right? So the first step in knowledge discovery process is collecting the data, raw data. And basically, you see, we live in an ocean of data, and not all the data is useful for us, right? So next step is the process of selection and cleaning, which is a process of transforming data into information, right? So this process data, or meaningful collection of data, something that is useful for us, is called information, right? So this selection and cleaning and transformation process provides us transformed data, which is called information, right? And there's a process called analysis. This process is to find patterns and interrelations in that meaningful set of data, right? These patterns or hidden relations or the practical insights is called knowledge, right? So the collection of logic that we gain out of the process data or information is called knowledge, and knowledge is used to make better decisions, right? To manage, a real life environment, right? So these steps are actually, we can put these four steps in the form of a pyramid. This pyramid is called DIKW pyramid: data, information, knowledge, and the application of knowledge or wisdom. Right? Now, the lower two layers, the layer where we deal with data and information, this is something like the acquisition of data and transforming this into information. Generally, we used to do this with the help of pen and paper. So most of time, like in a paper-based record system, the data is acquired manually, and the record keeping is done using papers. Right? This was the conventional way of handling data and information. Okay. What happened in last 15 to 20 years? We automated this process of data acquisition and transformation of data into information, and this process of information management, which includes storage. It all starts from acquisition. So acquisition, storage, and distribution of information is managed with the help of computer technology. And this domain of information management has been converted into a business. And we, as an Indian society, as well as our Indian economy, utilize or encash this opportunity. And for the last 15 to 20 years, this domain, which is also called IT or information technology, managing information with the help of technology, this domain has generated more than 40 lakh jobs in last 15 years, and there are many companies emerge in this domain like Infosys, Wipro, TCS, right? Okay, but now this is the point. This is the point where technology is transforming. Now, if you look at this upper two layers, knowledge and wisdom, in last 15 to 20 years, we have never thought about this. So most of times, whether you take a business case, or you take example of an industrial process, or you take example of any real life task, let's say driving car. In most of the this scenario, the knowledge discovery means the analysis part and applying the knowledge in the real life scenario, that means the wisdom part. These two layers are still manual. This is where the technology has not penetrated into, right? So the idea that Mr. Kevin Ashton coined was to automate these two upper layers. The IT is still there, but let us take IT to the next step, and this next step is IoT. So IT is evolving into IoT. Right? So IoT is not just technology which is going to replace IT, but IoT is technology which is a natural evolution of, it's a natural evolution of IT domain. Okay. So let's say, what will happen if you automate these two processes, knowledge discovery and application or decision making process? What if we hand over or delegate this responsibility to same computer which is responsible for acquiring data and transforming this into information? Okay. What will happen? See, if it is done, you'll see the products or processes are live like this. So a driverless car, it's a very famous project from Google. A driverless car is the best example of a fully autonomous, self-reliant computerized system in which all the four steps of this DIKW pyramid have been automated. Right? So very soon we are going to witness more products which are going to be self-reliant as well as fully autonomous. So generally, this in the industrial domain, the same technology. See this the example, driverless car example, is the example from a commercial domain or real life domain. Now, when it comes to industry, this Internet of Things technology is being called the fourth industrial revolution. So it all started from steam engines, and today, like we are talking about big data, Internet of Things, and 3D printing. And you know why are we calling this technology revolution? Because last three revolution changed our lives. But this revolution is a bit different from those revolutions. This revolution is not just going to change our lives, but this revolution is also going to change us. It will bring differences in the way we think, the way we work, and the way we live. So this revolution is not just an economical revolution or a technical revolution, but this revolution is more impactful, almost 100 times more impactful than the last three revolutions were. Right? And the one of the example is like in industrial domain is the connected factories or smart factories. See, computers, we all know that computers do everything faster and in more efficient manner than us, right? So why shouldn't we utilize these capabilities of computer systems to automate each and every process in inside factories as well as in our day-to-day life, right? So if you look at this picture, in near future, almost all the manufacturing processes are going to be fully automated. The factories will run by robots, and robots will control everything automatically without any human intervention. And there are many negative side effects uh, of this revolution too. Like one of the side effect is somewhere around 20 million people are going to lose their jobs. Right? But most of these job cuts are actually low skill jobs. Right? So now we don't need people to do routine stuff. For routine stuff, anything which has been done with the help of machine, we don't need human beings there. Right? So anyway, see, at one point we are losing some around 20 million jobs, but at the same time, this revolution is going to create 4.5 billion new jobs, right? But this 4.5 billion new jobs are actually high skill jobs where we need the right set of skills. We need engineers who are having, good analytical skills as well as designing skills, right? So we need more designers, better engineers, those who are having innovative ideas, right? So this is an opportunity as well as a threat. Opportunity for those who are skilling themselves in the right direction, and threat for those who are still using those conventional techniques in delivering the products or services. Okay. So let us look at the technology roadmap. See, as I explained, This is the fourth industrial revolution. Same time, let us try to understand this through this picture. See, if we divide the technology roadmap, it all started from PCs in 1970. This era from 1970 to 1990 is called PC era. In this PC era, the technology users were human, and the user base was somewhere around 100 million. Right? The dominant company was Microsoft, and this era was largely dominated by data-driven technologies, data-centric technologies. Right? Then came 1990 onwards came the next era. This era is called Internet era. The number of users grew to 1 billion. Now there are more than 2 billion Internet users. Right? The driving force in this era was information, and the dominating company was Google. 2000 to 2015 is the era called mobile era. So technology transformed, and computers transformed and came in the form of mobile phones. Right? The user base grew to more than 5 billion. The potential users were human. The driving force was connectivity, and dominating company was Facebook. Right? Now 2015 onwards, now this is the era. This is the era which has started recently. This is the era which is called IoT era. Right? And if you look at this thing, uh, it is expected there are more than 50 billion, and now this number has gone up. So now it is expected that more than 100 billion machine users are going to be there. See, if you look at the difference between last free era and IoT era is that here the technology was being used by humans. So human user, 1 billion human user, 5 billion human users, but now these are 50 billion machine users or 100 billion machine users. It means this is the transformation. This is transformation. We as a human are not here to operate machines. We are not here to cook food. We are not here to drive our car. We are not here to wash our clothes, right? We are not here to do routine stuff. See, all this routine stuff or day-to-day activities, computers can do it more efficiently for us. So why shouldn't we why shouldn't we set these computers free? Why shouldn't we program this computer and let them work for us? So this is what is going to happen. See, IoT is not just connecting machines to each other. No, IoT is building a society of more than 100 billion smart, intelligent, self-reliant, computer-based autonomous systems which will be free to take their own decisions. So very soon you will find driverless cars on the roads. Very soon you will find a smart factory running where robots will be manufacturing goods, and most of our day-to-day processes are going to be automated. And this is what future is, right? So IoT is not just Internet of Things. It is more than that. It is a revolution which is an opportunity for us to build a parallel society. Just like our society will build a society bigger in size than us. We are only 7 billion. There is going to be another parallel society of 100 billion intelligent machines which will run in parallel with our society, right? So this is what IoT is all about. Okay. Now, if you look at the use cases of IoT, see, IoT has touched almost all the areas of our day-to-day life, from connected health to connected cars to connected industry or connected city, or also called smart cities. Smart city is one of the project where all the governments have been investing lots of money, right? Connected energy, connected living and working. So almost all the areas of our life have been touched by this technology called IoT, right? Now, let me take example of one of the area. See, it is expected that by 2020, almost 90% of our cars and other vehicles are going to be connected vehicles, right? It says there is study says 250 million vehicles will be connected and fully pegged with sensor technologies. Connected vehicles will produce 350 MB of data per second by 2020. Right? This data will be utilized to manage the end-to you know uh, uh, transport. One third of consumer data will be stored in the cloud by 2016. In-vehicle software will be updated over the air. So there is technology called FOTA, firmware over the air. Right. So FOTA is like updating the firmware of machines. In this example, cars over the air, so through remote accessing. So this is one of technology which is being utilized by Tesla right now. Tesla Motors is using this technology to update the firmware of their cars remotely. The same technology FOTA is being now almost all the manufacturers are going to use the same technology of in the mainly as in-vehicle software update. Okay, so this is one of the area. If you look at other areas, it is expected that this is going to be a $1 trillion economy. The estimates from G and Cisco, they're forecasting this market to grow to $19 trillion by 2020 or max 2025. At the same time, this $1 trillion economy is also going to generate billions of jobs, right? So it one side, we are due to automation we are going to lose few million jobs, but at the same time this emerging technology is also going to generate billions of jobs. But most of the jobs, almost 56%, there is a 56% rise in freshers hiring. A recent survey says there is a 56% rise in freshers hiring, mostly those who are having right set of skills in IoT domain. Okay, so companies are looking for like innovative engineers who can help them in designing better products and will help them in surviving this transformation. Okay, so it's an opportunity for manufacturers as well as it's an opportunity for businesses as well as it's an opportunity for individuals. So those someone who is planning a career in this domain, this is the right time to jump into it. Okay. Now let us come to the technical discussion. So I just introduced the concept behind IoT, the idea behind IoT, and the market forecast. Okay, coming to an end-to-end architecture of IoT. When we look at end-to-end architecture, there are different components of this IoT system. This each component is a system in itself. So let us call this IoT is a system of systems. Right? So each IoT endpoint is also a subsystem, and these endpoints are connected to internet infrastructure, with the help of IoT infrastructure called routers and gateways. So endpoints, routers and gateways, these are actually IoT infrastructure. The internet infrastructure, which is internet is a communication infrastructure. It is being used just as a communication infrastructure in this IoT domain. And a third component which is playing a supporting role in implementation of IoT right now is cloud computing. right? So cloud offers analytics and storage in the form of service to us. Right? So these services are being leveraged and to implement IoT in a practical manner. Okay. So the idea is to offload more and more computing load on the cloud to reduce the device level complexity and to reduce the power consumption of our end devices. Most of these end devices are like, let's take example of wearables, your smart wristwatch or your smart shoe or your smart glass or a smart car, or let's say a smart refrigerator or washing machine or ACs or traffic signals. These are endpoints, right? So we to reduce the power consumption, we could not afford to put lots of computing loads on endpoints. So most of the time the strategy which is being utilized right now is offloading the analytics to cloud so that device level complexity reduces and the power consumption of the end device also reduces, and it becomes possible to run the end devices on batteries. So most of the IoT devices are going to be battery operated devices. This is why we need to take care of power consumption. Now, if you look at the architecture of endpoints, the endpoints are these endpoints are having these four capabilities embedded into them. The most important capability is computing, second is sensing, and third is actuation. So if we embed sensing, computing, and actuation capabilities into a thing, it becomes a smart thing, and in technical language we call it embedded systems. Right? Forget communication right now. Let us talk about these three capabilities. If we embed these three capabilities, sensing, computing, and actuation into anything, let's take example of your wristwatch or take example of your shoe. Let's say if you embed these three capabilities into a device or a thing, it becomes a smart thing, right? And we call it embedded system. The fourth capability is communication. The moment you add this fourth capability in, or you embed this fourth capability into your thing, it becomes an IoT end device. Right? So these IoT end devices are basically a natural evolution of embedded computing with communication or connectivity to the cloud, representing the next step in the evolutionary ladder, right? So this three component makes a system smart. The fourth component, smart plus connect, will make it an edge node or an end device of an IoT network, right? So there are many examples of this IoT end devices. If you look at the automotive sector, your all the cars, right? Car access, powertrain, safety, bus controller. Most of this lifestyle, healthcare, residential, energy, industrial. Almost you'll find many examples of these end points or end devices, which are actually a part of IoT nowadays, right? So what do we need in this end devices? If you look at the architecture carefully, what do we need? We need a very good mix of performance, scalability, compatibility, and energy efficiency. So these are our design vectors. These are our parameter we need to optimize when it comes to designing end devices, right? So a good mix of performance, scalability, compatibility, and energy efficiency is something desired in end devices. Okay. Now, when it comes to designing these end devices, obviously the first selection the first component we need to select is sensors. Okay, most of you are from engineering background, so you know how difficult it is to select the right sensor, because the choices are almost unlimited. You know, there are different types of sensors: pressure, force, vibration, temperature, light, and as many like sensors are there, as many physical parameters are there, right? So sensors acts like eyes and ear of computer systems, right? And selection of the right sensor is a challenging task. So there are many factors on which this selection is based. Anyway, this is in this presentation, I don't think so we have enough time to discuss all these parameters, but there are many parameters like range, sensitivity, and the uh, type of signal we receive from sensors. So there are analog sensors, digital sensors, and so on, right? Okay, when it comes to second component of an endpoint device, it is a microcontroller or a prototyping board. So this microcontrollers, as you can see on these boards, these chips are mounted, right? This mounted chips are actually single chip computers. Why I am calling them computers? Because a computer is a combination of four components: uh, microprocessor, which processes our instructions; ROM, which acts like storage memory; RAM, which is used as processing memory; and ports, the logic circuits, which provides us a physical point to connect our external devices with computer systems, right? So now the VLSI technology, very large scale integration, the VLSI technology has advanced to a level where we are able to fabricate all these four components inside a single chip. So actually all these chips are having microprocessor, RAM, ROM, and the logic circuits to create ports fabricated inside them, right? And there is term being used nowadays, SoC, system on chip. If we have more than these four components fabricated inside same chip, we call it SoC, system on chip, right? So nowadays you will find that it's not easy to program and handle this single chip computers, and this is why designer community has come up with this type of handy prototyping boards, where the single chip computers are mounted on a board which can be plugged into a computer system directly, and you could write a program and upload into this microcontrollers or single chip computers, right? So there are few families which are open source and which have become industry standard now. One of the family is Arduino. So most of these boards, as you can see on my screen, are from Arduino family of prototyping boards, and one on the right side is a single board computer. This is not a single chip computer. This is a single board computer, which is an economic replacement of desktop and laptop computers. This single board computer is called Raspberry Pi. So there are hundreds other prototyping platforms introduced by all the major vendors, major manufacturers like Intel. Intel has launched this boards called Galileo, and now the recent version is Intel Joule. So these boards are good learning platforms when it comes to learning IoT. Okay, so Arduino and Raspberry Pi, these are two entry-level development boards, and there are more boards. But if you want to learn everything from basics, these are good choices. Anyway, there are many other factors why we prefer to use these boards, and one of the factor is that the single chip computers mounted on these boards are highly energy efficient. At the same time, they are high performance. These are high performance computing computer systems. Okay, let me give you an example. The processor mounted here is capable of executing 16 million instructions in a second. So the throughput of this microcontroller mounted on this board, the throughput is 16 MIPS. 16 MIPS. MIPS stand for million instructions per second. So these are not normal ICs. These are powerhouses. So these computers are high performance computers. They consume very less power. It runs at 3 milliampere current only. And third thing is there is a very good mix of IOs, so you can connect your sensors directly with the this single chip computer or microcontroller. It provides you the a good mix of IO interfaces where you can connect your sensors and actuators with this computer and can design IoT end devices. Okay. Now, when it comes to Raspberry Pi, this is a ARM-based computer system. ARM stand for Advanced RISC Machine. RISC stand for Reduced Instruction Set Computers. I think you all might be aware of this thing. That RISC is the dominant architecture right now, and almost 98% high-end embedded systems, commercial domain as well as industrial domain, use ARM-based computing platforms, right? So Raspberry Pi is one of the platform which is using this ARM SoC as CPU. So this is again a second platform which is very energy efficient as well as low cost. The Raspberry Pi board costs only 3,000 rupees, the Pi 3, and it comes with onboard Wi-Fi as well as Bluetooth communication capabilities as well as HDMI output LAN connectivity and 4 USB ports with 40-pin header where you can connect all low-level peripherals with this board. Okay, so the potential use of this Arduino boards and Raspberry Pi is Arduino boards are uh, preferred to be embedded into end devices. Right? So most of the end devices, if you want to design your own device, the best choice is to go for this thing, Arduino boards. Okay, Raspberry Pi, because the speed is around 1.2 gigahertz, so it's a better choice to be used as IoT router or IoT gateway in IoT networks. Right? So these are two good choices when it comes to selection of right computing platforms to build IoT devices. Okay. Now let's come to the communication part. So selection of sensors, selection of right computing platform, and third and the most challenging task is selection of the right communication technology for your device. See, there are many options available to us, ranging from NFCs to WiMAX, right, or LTE. But the most popular choices are Bluetooth and Wi-Fi. So the current a recent version of Bluetooth called 4.0 is, or BTLE, Bluetooth Low Energy, is the recent addition in Bluetooth family, which has been designed specifically for IoT devices. Right? So almost 65% smart devices use Bluetooth as a communication technology. Okay. Now, when it comes to internet access or connecting your devices to internet, the best choice is Wi-Fi. Right? Now, Bluetooth and Wi-Fi are the dominating protocols in IoT domain, but still this protocols needs lots of revisions. Okay, and this is the reason why the newer version of Bluetooth are going to be launched very soon. The newer version of Bluetooth is Bluetooth 5.0, and Wi-Fi is Wi-Fi Hello. So Wi-Fi Hello and Bluetooth 5.0 are the newer Bluetooth and Wi-Fi standard which are going to be launched shortly, and with the launch of this newer protocols, the M2M communication and IoT will altogether will take a different shape, right? So anyway, these are the choices available to us when it comes to connecting our devices to each other, which is called forming an M2M network, or connecting our devices to internet. Bluetooth and Wi-Fi are best choices. The other options are Zigbee, which is a very popular protocol in especially in home automation domain. Okay, so these are the areas these are technology which can be utilized or can be used to connect your devices to each other, right? Okay. Now, once we design this end device, with the right set of sensors, computing platform, and communication technology, as well as actuators, the next challenge is to connect this to cloud. So most of times, see, internet is a communication network where all the devices speak a common language, right? And TCP/IP is one of the language or protocol which is universally accepted protocol. TCP/IP is a protocol written by IETF. IETF is the Internet Engineering Task Force. Okay, so IETF. And actually, TCP/IP is based on OSI protocol stack. OSI has 7 standard layers. It's a IEEE standard. Okay, so TCP/IP has only 5 layers. Okay, uh, but at different layers, different protocols are being used. So one of the major change which is taking place here is that from at network and link layer, rather than using Ethernet, we are preferring to use Bluetooth, Wi-Fi, and Zigbee. Okay, so Bluetooth, Wi-Fi, and Zigbee, these are the new data link layer protocols which are dominating when it comes to end-to-end communication through internet. Okay, at network layer, the IPv6 is a newer protocol which is replacing IPv4. The reason is IPv6 is uses 128-bit IP addressing, while IPv4 uses 32-bit IP addressing mechanism. So because we are expecting that 100 billion devices are going to be going to join, are going to be connected to internet. So we need more number of IP addresses, and this is the reason why IPv6 is replacing IPv4 now. It uses 128-bit IP address, and with the help of 128-bit IP address, we can connect more number of devices to internet. Okay. When it comes to transport layer, the UDP is gaining popularity over TCP. The reason is UDP is a lightweight protocol. Now in IoT domain, we need lightweight protocol. We need to reduce the complexity at the device level, as well as we need to reduce the complexity of at the communication level to reduce the amount of data volume, as well as so that bandwidth consumption will also reduce. At the same time, making the this communication system a real-time system, right? So this is the reason why UDP is getting popularity at transport layer. When it comes to application layer, the newer family of protocols are CoAP, MQTT, XMPP, and AMQP. The most interesting thing which is common in all these 4 protocols, CoAP, MQTT, XMPP, and AMQP, is that this group of protocols are called message-oriented protocols. Right? So this is a new thing. Even internet is also transforming with IoT. We have been using internet for the last 15-20 years as a client-server architecture. So internet is based on a client-server based architecture, but now it is getting transformed. The newer architecture is publish subscribe architecture, right? So like we need to make almost each and everything more efficient, including the communication through internet. Okay, so this is why this newer protocol stack, and there are lots of work is going on in this domain to design new protocols. Okay. Now the end point is of course the cloud, and the cloud is an internet-based infrastructure uh, which you know takes data from the end devices, and we can store the data on the cloud. It offers us storage as a service. At the same time, we can also leverage computing power of the cloud to perform analytics of our data. Right? So analytics is something, analytics is all about extracting the practical or let's say valuable insights from data to make informed decisions, right? So this is something that is being implemented on the cloud side. So there are many commercial cloud platforms, like if you talk about ThinkSpeak is one of the very popular, computing cloud platform which is available free of cost. Right? So ThinkSpeak is one of the cloud platform. Amazon Web Service, AWS IoT is another very popular protocol, popular cloud computing platform. Microsoft Azure, PubNub, right? So there are many cloud platforms offering different set of services of offering like a storage, offering different types of analytics you can perform on your data, the visualization tools, as well as remote controlling your devices. So you can program alarms, and you can program timers to take any action based on your choice of data, right? So this is something that cloud can do for you. Okay. So let me conclude all these things. See, with the help of all these technologies, like when it comes to this thing, generally people think that IoT, big data, analytics, all these are isolated technologies. But this is not the case. See, IoT is an ensemble of all the technologies we have invented so far. So now, when it comes to learning IoT, you need to have very good and sound knowledge of sensor technology, uh, microcontrollers, prototyping platforms, communication technologies, uh, internet, internet as a technology, as well as the protocols being used on the internet, right? Cloud computing, different architectures of cloud, data analytics, and the tools being used for data analytics, right? So the right now the best tool for data analytics being used by most of the data scientists all over the world is Python, right? So R and Python, these are the two leading languages. Python is gaining an edge over R. The reason is Python is many supportive packages like SciPy, which is with a very good collection of scientific methods you can utilize to perform different types of analysis on your data. Scikit-learn is another Python package which helps you to program many algorithms. There are many methods and algorithms available to you, and you can utilize those algorithms to implement machine learning on your machines. Right. So the future is see, IoT learning. IoT means learning all these technologies. From sensors to cloud computing, including analytics and programming languages like Python and machine learning. Okay. Now, most important, let me conclude this with one thing. The future of IoT is uh, you know to bring analytics and to bring analytics from cloud to device. See, right now, why we are dependent on cloud? Because our devices are not capable of affording the computing load. So what do we do right now? What we have been doing, the data acquisition, and transforming this into information is implemented on the device, but then we send the data or information to cloud for further processing or analysis. Now, once these devices become richer in terms of resources, what I mean to say is processing speed and the amount of memory, as well as, with reduced power consumption. Right? So once the devices becomes richer and we are able to reduce the power consumption of our end devices, our dependency on the cloud would be less, and we would be able to implement, or we would be able to put the analytics back into our devices, right? So the future is our dependency on the internet will be less, with time. So most probably after 5 to 10 years, you will find that the devices will have their own communities, and the local interaction will be more rather than communication, right? So this is the target of IoT, building 100 billion devices and connecting these devices to each other. Let's go for more local interactions and less global communication. Right? So with this, I'll just conclude my session here. And if you have any doubts or queries, please raise your hand, or let it come through Professor Rajeshwari. I'm here to answer your questions. Thank you.